Okay, so we were dealing with objects where we're just going to take an object and it's just going to fall, come down to the ground and hit the ground, or just a free-falling object. Now what we're going to do is this. We're going to take an object and toss it up in the air like this, and it's going to go up, 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 up in the air, and then come down, 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 down. And so this is where we're actually giving that object an initial velocity. So let's actually just say that we're tossing the ball up in the air. And so describe me this. How does the object move? Does it go up and then get faster and faster and faster and faster as it's going up? No. Well, wait a minute. That would actually describe like a rocket ship, right? So when you toss a ball or an object up in the air, what happens? It goes up, 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 up. Pause, and then down, 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 right? So it actually starts off really fast and then starts to slow down for a brief moment. It pauses and then it starts to drop faster and faster, and then bam, it hits the ground, right? So that's actually describing the object's trajectory. I know that you used this term before. The object's trajectory is what we're describing right here, which is the path of the motion. Okay, so say if we actually have now I just want to also describe this. Hey, you know what? We're just throwing the ball straight up and it's coming straight down. I can't really depict that in this illustration. So that's the reason why I'm actually having it go up and to the right and then down and to the right. It's not a exact and perfect depiction that I actually have right here, but it's kind of the best I could work with, considering the idea that I wouldn't be able to show this going straight up and straight down as nicely. So anyway, we just said before, we're going to be throwing the object up in the air, right? So we have to give the object an initial velocity. So let's just say that the initial velocity is 29.4 meters per second. And this is at time of 0. So let's just do this. Let's say that we have our velocity, our time in seconds, and let's write our direction. Okay, so at time of 0 seconds, what's the initial velocity? Oh, it's 29.4 meters per second. And what's the direction? Well, we're tossing it upwards, right? Okay, so we know that acceleration due to gravity is negative 9.8 meters per second squared. And once again, what this means is for every 1 second, the object's velocity will change by negative 9.8 meters per second. That's what acceleration is. It's a change in velocity over a certain amount of time. So if our initial velocity is 29.4 meters per second at 0 seconds, then after 1 second, what is our object's velocity? So let's say here it's at 1 second. Well, our object's velocity will be the 29.4 minus the 9.8 meters per second, giving us 19.6 meters per second. So over here we have 19.6 meters per second. Okay, well, what about after 2 seconds? Where's our object's velocity? Well, 19.6 minus our 9.8 gives us 9.8 meters per second. So we have now 9.8 meters per second. Notice that our object's velocity is starting to slow down a bit. Okay, and the direction is still upwards. What about after 3 seconds? Well, we're going to subtract 9.8, so we have our 9.8 minus 9.8. What does that get us? 0 meters per second. And does that make sense? Hey, you know what? When you toss an object up in the air, it goes up, 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 up. And then what does it do? For a brief moment, it pauses, and then it comes down, 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 down. Right? Isn't that the way that the object's trajectory actually goes? So all the way at the top over here, the object's velocity is 0 meters per second. And that should make sense. So what is the object's direction? Hey, you know what? It doesn't really have a direction. I'm not even gonna draw a, so we're just gonna keep that blank. Okay, well, what about after 4 seconds? Wouldn't it just be negative 9.8 because we have 0 minus 9.8, and that gives us negative 9.8. So we are over here, and we have a negative 9.8. And what is our direction? Our direction is now downwards. So now our direction is downwards. And once again, what does this negative represent? That's a downwards direction, right? And we're just going down a little bit. What about after 5 seconds? What is our object's velocity? Hey, you know what? It's going to be 19.6. Negative 9.8 minus another 9.8 is negative 19.6. And what is its direction? It's also downwards. So downwards of negative 19.6 meters per second. And what about for the last one? 6. Hey, you know what? Do you need to do this calculation, or are you starting to notice a pattern? Maybe you're starting to notice a pattern here that we'll actually have 19.6 minus 9.8 gives us a negative 29.4 meters per second. And we have our negative 29.4 meters per second. And the direction is once again downwards. Notice, check this out. Look at this symmetry over here. We're launching this object up at 29.4 meters per second. And what is it doing? It's going up to the peak where it actually just pauses for a brief moment and then it comes down and it hits the ground at the same speed, just in the opposite direction. So, yeah, you know what? We actually do have a nice symmetry over here. All right, so I know that I just spent a lot of time going over how the trajectory is very symmetric based on the velocities, but what else is very symmetric? Well, what about the time? How many seconds does it take to go from the ground all the way up to the maximum height? 1, 2, 3 seconds. And how much time does it take to actually go all the way down to the ground? 4, 5, 6. Another 3 seconds. So, hey, you know what? It takes, for the time for the object to rise all the way up to the max height, 3 seconds. And for the time for it to fall back down to the ground, another 3 seconds. For a total time of 6 seconds, right?